Okay, so we're looking at exercise 67, which is it is estimated there are currently 5 times 10 to the ninth cell phones being used worldwide. Assume that the average cell phone measures 5 inches in length, and there are 5,280 feet in a mile. All the cell phones currently in use were to be lined up next to each other, tip to tip. How many feet would the line of cell phones span? Write the answer in scientific notation. So what we need to do here is we need to start with converting this number of things, the number of cell phones, into a length. And so if each one is 5 inches, we can look at the total length of the cell phones. So I'm just going to put over here length equals 5 inches for each cell phone. But we have 5.0 times 10 to the ninth cell phones. And this is inches per cell phone. If we're going to get pedantic, we can actually let our units cancel out like they're mathematical things. What we'll find is the 5 times the 5.0 gives you 25.0 times 10 to the ninth inches. So that's the total amount of distance that all the cell phones will cover. Well, this is the same in proper scientific notation as 2.5 times 10 to the 10th inches. And notice that's because this portion in scientific notation needs to be between 1 and 10. It actually has to be greater than or equal to 1 and less than 10, so it can't actually be 10. And so 25 is bigger. We can think of it, we can rewrite 25 as 2.5 times 10 to the first, and that's multiplied by 10 to the ninth. Our rule of exponents makes 2.5 times 10 to the 10th. So we can rewrite this number as this, and this simplifies our scientific notation. But it wants to know how many feet there are. And so there are 12 inches in a foot. 12 inches in a foot. And so we need to divide this by 12 to find out how many feet we have. So 2.5, get this up here. I'm going to put this up here, times 10 to the 10th inches divided by 12 inches per foot. And so running off to my trusty calculator here, I'm going to put in my 2.5 EE. Most calculators have a key for engineering notation, so it'll be EE. 2.5 EE 10 divided by 12. And I get a repeating fraction here, but we can use 2.08333 repeating times 10 to the ninth feet. And so when we're working with notation like this, it's usually good to keep the number of decimal places low. I want to keep this fraction for now until I work on the second part of the problem. Let's see what it wanted for us here. Write the answer in scientific notation, and we've got a repeating decimal. So we're going to truncate this to 2.083 times 10 to the ninth, just for now. And when we do the next part, we'll probably round one more time. So the circumference of the Earth measured at the equator is 25,000 miles. If the cell phones in part A were wrapped around the Earth at the equator, would they circle the Earth completely? So we've got this in feet, but this question is now asking us to compare it to miles. So we're going to do one more conversion. So there's 2.83 times 10 to the 9th feet. Oh, let me get my times looking correctly here. But the question tells us how many feet there are per mile, so I'm going to do the same thing. I'm going to divide that. And if we look back up here, there are 5,280 feet per mile. 5,280 feet per mile. So if I do this division, so luckily I have this previous answer saved in my calculator. So I hit my answer button and divide 5280. And I get 3.945707 repeating times 10 to the 5th miles. And so what is the circumference of the Earth? The circumference of the Earth is 25,000 miles. Well, 25,000 in scientific notation, 25,000 miles can be written as 2.5, 1, 2, 3, 4, times 10 to the 4th. And so our cell phones cover more miles than the Earth. So if I imagine them laying them down, I lay cell phone 1 down and so on, I'll eventually get to 2.5 times 10 to the 4th miles, and I'll still have some left over. So we want to know how many times this goes around. So we're going to divide the bigger number, the number of phones we have, by once around. And this will tell us how many times we can go around. So 3.945707 repeating. Not rounding right now. I tend to like to round for final answers. Ten to the 5th miles. Divided by 2.5 times 10 to the 4th miles. Now, if you're nice, you have a calculator that lets you scroll up to previous answers and grab them, you can put them in. If not, you can just type in everything to about 5 decimal places. Should be good enough. So we start with our bigger number. That divided by our smaller number, which is the 2.5 EE4, and we get 15.7828 repeating, or approximately 16 times. The book might tell you it goes 15 times exactly, and then you have a little bit left over. I would approximate this upwards to 16. And for most of these, you only need 2 decimal places to really get an idea of what's going on. But when you know numbers are going to be used later in calculations, store them on the calculator, or keep about 4 or 5 decimal places so your rounding doesn't throw off your results.